In this example, we'll see why sticking to for loops that have a step size of 1 can be very helpful for evaluating different situations. We're going to start this demonstration by going back a couple of slides to example 1, where we were trying to analyze a piecewise function. So going back to the function we made a couple of slides ago, we came up using if statements and else if within there. We had the three pieces of our piecewise function defined between when x is less than -1, between -1 and 5, and when it was greater than 5. And we saw this was called L03_EX1. That we could evaluate this just fine at discrete points. So for example, -5, we came up with a value. We saw that for 3 we came up with a value, and for 15 we came up with a value. And those were all correct. But our ultimate goal in the problem was to be able to plot the function between -10 and +20. And what we saw was if we tried to put a vector in, it wasn't working for us. The way we constructed our piecewise function using that if statement, it was not able to handle vectors. And there's not really a way to fix this easily because, again, we're using those if statements in there. So we had to evaluate this only one value at a time for it to work. So as we discussed in the previous slide, if we can vectorize, that's our the first thing we want to try. In this case, we can't put a vector into this particular function, so if we want to be able to find multiple values of it, we do want to use a for loop here. So let me get rid of this. Alright, so we can use a for loop. So we do want to go between the bounds of, for example, -10 to 20. So one thing we can do is we can just evaluate the function at those values. So it will evaluate it at -10, -9, -8, etc. until we're up to 20. And if we run this section, it does that just fine. It can print it out to the command window. But if we try to save it into a vector I'll call y, it's not going to be able to do this because the way I'm indexing here, I'm starting at -10 and I'm trying to fill in the value for y of -10, and I can't do that because I can only use elements that are positive integers, so y of 1, 2, 3, 4, to fill in the first, second, third element of y. So doing it this way won't work, and in addition, if I wanted to say, even if I could do this if I went from 1 to 20, it does fill it in, but we're not getting the whole range. But additionally, if I want a little bit more refinement, say go in steps of 0.5, it's not going to work there either because, again, k is taking values that are not positive integers. To remedy this, I can use k, not evaluate k, but use k as what I call an index variable or a dummy variable. So what I'm going to do is I'm going to make a vector x that's going to go from -10 to 20, and I'll refine this. I'll just start with a linspace here. And I'll use just 100 plot points for right now. So I can define this vector x, and this is actually what I'm going to use to do my evaluation. Now again, I have this vector x, but if I try to put it directly into my function, it's not going to work because, again, that if statement is there. It doesn't like doing that. So what I want to do is evaluate the values in x one at a time. So I'm going to use k as, again, my dummy variable here, or my index variable, and k is going to iterate through the values of x. So I want to go from value 1 to a value length of x. So what it's going to do is one at a time, it's going to go through the first element of x, the second element of x, etc., all the way through. So here, instead of evaluating k, I can evaluate x of k. So again, on every iteration, this x of k changes because it's going to be the first value of x, then the second value of x, the third value of x, etc. Now what has changed here from how I was previously trying to do it and it wasn't working? If I see here, k is now going from 1 to the length of x. Both of those are integers. I'll explicitly put it here, but this is always the case for using dummy variables, that it's always going up by a value of 1. So what did this change? If we look at how y of k is being used now I can put y of 1, then y of 2, then y of 3, all the way up to, for this first example, y of 100. So this will be able to fill in those values of y very effectively. So now if I run this bit of code, it didn't give me any errors, and I see in my workspace here that y has 100 values to it. Right, so we can keep looking at the time comparisons also. Right, so what can I do with this? Now I can actually plot my function. So my horizontal axis is x, my vertical axis is y. And clean this up a bit. Turn this into a black line. Right, so again, this is now our function, our piecewise function, evaluated from -1 to 20. Now some things to keep in mind. The way I'm using y here, I did not pre-allocate, so even though we can't use vectorization, I can pre-allocate y to make this a little faster. And we should always be thinking of this when we're using for loops, is this pre-allocation. So I'm going to pre-allocate with zeros. And we see that does run faster, but again, it's just a good habit to be pre-allocating here. And to reiterate why this is helpful to use this indexing, or these dummy variables, is if I go back, I can change x. I can actually use more elements. I can use 1,000 elements here, and everything else is going to work just fine. So if I run this, I now have 1,000 points for y to the 1,000 points of x, and I get my piecewise function here plotted correctly. And to recap, what I'm doing a little bit differently when I use this index variable or this dummy variable, I'm only letting k take positive integer values, that's my index, and I'm doing that so that I can assign the first, second, third, fourth, etc. values of the vector y. And on the right hand side here, instead of using k as the value itself, which can work but is not recommended, I'm taking always the kth value of some vector, in this case my x vector, and evaluating my function with respect to that.